Welcome to this OrthoVista tutorial. In this tutorial we want to show how we can use data that was processed in a previous time. Let's for example say last year we have some orthophotos and we generate mosaic tiles from them, and then we fly in the next year new data, new orthophotos, and we want to replace partially mosaic tiles from the first flight, because the first flight was perhaps covering the whole project or the whole area, and now we only flew a smaller portion, or we continued, we want to run perhaps a project in two parts, and we want now to apply corrections to our new orthophotos in relation to our old data. To showcase this, we will do this here with this example. We see here on the screen these three strips, and let's assume it's not only these three strips. This was now flown through all the tiles, so also here in the lower part in the south we would have similar images that were flown with similar light conditions like these ones here. And so we have everywhere tiles from the last year. So I will just talk, for example, this was in the year 2018 was a flight. And then we have now new data, which is here in the lower part, which is now flown in the year 2019. And we want now to create the mosaic tiles that they fit to the radiometric content from the previous year. And so we see here, we have here another data set that has different radiometry. And so we want now to try to get this data fitting to the upper part of the data. So this will then be something like our reference for the new data that is coming into it, which was not existing last year. And either you already had here data, you were flying the whole project, so there are already here images existing similar like the ones here we see, or you don't have any data and you just want to continue now to make this work with the new data set. To make this work, you will need to have overlap between data flown from the last year and the new year. That means if you have these orthophotos here and then you fly new data, then you need to have overlap to these orthophotos. The reason is, for these orthophotos that were processed in OrthoVista for the mosaicing, we have for each of this orthophoto metadata, and we have the global tilting files called TLT, and they exist for this process from last year. And we will then have a meta folder which includes already the TLT files from these orthophotos. And then we will then add the new orthophotos, which will then be these new ones here. And these new orthophotos, they don't have TLT files, and because they overlap here to the old orthophotos, the TLT files from the old dataset from 2018 will influence the new orthophotos from 2019, and we can then here make the corrections. What we can do is we can do radiometric corrections from the radiometrics, and to bring this data as close as possible to the previous data. And therefore then we can then run the global tilting with better starting values for the new data from 2019. We will simulate here this part by running the mosaicing for the tiles for the dataset from 2018, and we will generate the mosaic tiles. You can choose if you want to run this row of tiles or not, because later on when we get the new data, then we will rerun these tiles. I will now create them, and then they will be replaced in the second run from our process with the new data from 2019, which will of course still have a content from the 2018 images in this upper part, and then hopefully be seamless to the new data from 2019 in this part down here. In this video for us, it's more important to see how to work with the meta folder. So typically you would make here already some corrections with radiometrics for this starting data to enhance the radiometry, to try to make your histograms as good as possible used. I will not go into this part. I will just run the process and show how to administrate the folders, how to handle the metadata folder, how to copy the TLT files if they are not in the right place, in the right position, so that we can then run for these two data sets a good complete data set run. Of course, you will have to use the same TSP file for the tile definition, so that we have here seamless tiles created, and so we can easily replace then the previous generated tiles with exactly the same tiles in the new run from 2019. It is very important that we know the metadata folder used from the 2018 dataset, because we will need to use the same metadata folder also for our 2019 data, or either we need then to copy later on the TLT files so that we can then use them for the 2019 run. I will keep here the default setting. OrthoVista will always create a meta folder into the output directory, and so I will then reuse this metadata folder later on with my 2019 data that will then become in, just that we are aware of it. I will run here, as I mentioned, with standard settings. I will just use a global tilting where I will run it on 3 iterations, and I will here just run on intensity just to make it as quick as possible, just that we see how they will fit to each other. Of course, if you have color differences, if you have some color shiftings or contrast problems, you can use them. For us here, it's only to show here the corrections. And of course, later on when we will bring the second data set to the first one, then we will also need to do some color correction. But for me now here, I will stay with this TLT correction and say okay. Very important is also the seam lines. If you want to reuse seam lines because you want to apply them to the new dataset, this is very dangerous, because the orthophoto extension and the perfect pixel size of each orthophoto is not given with the new one perhaps. Perhaps you have the same exposure positions, but it doesn't mean that you can just easily reuse the seam line again. So be aware, for me here at this demo, my important thing is the tiles. So I will just run here on this tiles with the new data and then replace the tiles from the previous run. The seam lines will be also generated for the new data set, but independent from it, I will just use the content to fill the mosaic with it. And if you want to reuse seam lines, as I mentioned, be aware the seam lines, the CLD files, are bound to the extension of the orthophoto itself and also the image name, so it's very complex. I would be there careful to do this. Then we will save our mosaic output, so all these selected tiles will be written, and we will then take a look at the result after the process is done. As I mentioned, this is some simulation, so I already have this data here because I wanted to show you this will be overlapping. In reality, of course, in my 2018 dataset, this data does not exist and will not be able to be used, and exactly this is what I simulate here. 9 of these 40 images here at the bottom here, they are touching my output folders, but they are not active and they will not be used, exactly as if the flight does not exist here at the moment. And so I will ignore these images and just continue with the active images to process. Okay, so let's take a look at the result. We have here some demo data, which is very small. We see here in 2018 the mosaics have been written, and in the metadata folder we have here this TLT files, which is from the global tilting for the 2018 used orthophotos. And these TLT files are important for us. They will now be reused for our new dataset, so we will need to use the same metadata folder in our next process, where we will now add the new orthophotos. But as mentioned, we also need to use the last row from here, from these images, to be used for our new process. I will simulate this here just by deactivating the other photos and the two upper strips, and then I will activate the lower two strips with this middle strip, and this should then be exactly what will then be used for our 2019 process. I will just stop, and when I have done this I show you. To select the photos, I here just use the radiometrics part. And here I can select photos, and I will just select here the upper two strips, and then these photos are here selected, and then I can here deactivate them, and now they are not active. And then we will here also take the lower ones, so I unselect all, and then I select here the lower images, or I think I make it opposite wise. I activate all, and then I will now select only the upper two ones. Yeah, that's the easiest way. So here they are now selected here with radiometrics, and then I can say these are with radiometrics selected, and then I deactivate them, and this should now have shown me the content which how I wanted exactly. Yeah, these are the images that represent my 2019 flight. This strip here is representing my photos from the 2018 flight, so we see they are different. But for these orthophotos here, I already have now TLT files for the name of this orthophoto. Here, when I just open this one here, this is the orthophoto 1M50CMOR138. I already have here for this one a TLT file in the metadata folder, and for this new one here, 1M50CMOR15, I don't have a TLT file, and this is exactly what we will use in our processing, to use these TLT files to influence these new images for our mosaic generation. Let's perhaps also take a short look on our mosaics at the moment that we have, how they look like. So here we go. I just loaded them in a new OrthoVista, just that we take a look how the orthophotos look like compared now to our data. We see here, this is this data set here, and this was then creating this mosaics, and hopefully then we can now make the changes to the lower one so that they look similar to the upper one, to this one here. I don't say they are looking great, I just want to show how the process is going. So to make this work, again, we will first here select our tiles that we want to process. So we go to tiles, and we can either select them here, or in a graphical way, you can go here and say select tiles and make here an aerial selection, and I will reselect this row of tiles here. Sorry, I have first to deselect all the other ones here, and I will select these ones. So I reselect these ones, so they will be overwritten, and here are the new tiles that will be created. Of course, this can continue with multiple rows in this case here. Additionally, I want now to bring these orthophotos here closer to these ones, because with good starting values, we can then bring, of course, this data from 2 different seasons or 2 different years much easier together in an automatic way. So, and this will be done with radiometrics. So I will apply changes to the lower images only, make radiometric corrections to bring them closer to the upper one. And I will not go in this video about this process. This is something that we teach also in OrthoVista. I will just stop and show you then how I brought them back. So after the radiometrics correction, the lower 2 strips were brought closer to the upper one. We were running this with the color picker and with the histogram display, so we could here bring these ones closer. They are not perfect, they are just slightly bringing into the right direction. And when we look here, we still see here differences in the illumination. They are here more bright, here more dark. And of course also the when we go into more detail, we will still see here strong differences, which will then always be the problem when you go through your different years, because vegetation changed, the content of some acre fields changed. So this can always then still be a big issue, and you won't be perfectly be able to fix this. But at least we brought now the data closer, and now we will rerun these tiles, and then also these tiles that are overlapping here will be then replaced with the new content of the data. And we will run here this part. We will now create a new output in this case, and I will call this now here 2019. And very important, of course, now is that the metadata folder changes here, but I want to use the old one. So I want to use the metadata from 2018. You can also select it, of course, here this way. And in this folder, we remember we have here these TLT files, and they will stay. That means these orthophotos here will not be changed in the global tilting when we run global tilting here. But the new images now, they will be changed according to these reference TLTs that exist. So they will now have an influence on the correction from the other ones here. We will still run the seam line generation, which will then run here between the old and the new orthophotos. So hopefully the seam here will then be seamless later on, so that we don't see here a change in this tile itself, that they were moving from the 2018 to the 2019 orthophotos. And then we will save the mosaic, and because we saved this mosaic into a new folder, we will don't get a message. If you would use the same output directory, then a message would come, do you want to overwrite existing files? And then we would overwrite these tiles. But I will now create a new subfolder so that we see the difference between the previous generated tiles and the new one, the new generated tiles. So perhaps we remember we had here this part which stopped here at this part, and now these tiles will be hopefully filled completely to the bottom with the new data, but the content here should be the same. Hopefully, we will see. And so we can then run the process. You need to run global tilting, and the TLT files need to exist. Sorry that I repeat so many times the same thing. The RDX files from radiometrics, they are not depending on the output directory. They are stored directly with the photos, so you will not find them here, but directly at the images. So here with this image we have these RDX files, and these RDX files then exist now for these files that we now changed here in radiometrics. I will close and process, and then we will take a look at the result and see then how this was then applied. Okay, we are done. I will just load the new result into another OrthoVista. So here we go, and we can see here how the seam line was still moving from the old to the new one. The problem is, of course, the resolution. You see, this is not much more detailed, these photos. The new ones, they have been much more here done from blurred out in this case. Color-wise, perhaps we should have activated color correction for this global tilting, so that this will then also be applied to the new photos, so that we don't see here a difference. And I know from my data that the other one here has some color correction, so I will perhaps rerun it one more time with color correction. Hopefully we will see then here an even better result, which means I just go back here to our process here, and in my case here I will just run now the global tilting with adjust color, and then hopefully this will then look better, I hope. Okay, so I changed now with color correction slightly, and this brought now a much nicer result. And we can now see, when we look here at this 2019 data and compare the 2019 data with the 2018 data, then we have to look here at this lower part. You remember this was generated from the 2018 images, and this content is here, this content of the upper part, and then the remaining part is coming now from the 2019 image. But just that we see here, okay, this content here is this content, has not been changed, and then it goes into the 2019 part. I will now load all the tiles together in a third OrthoVista, so that we see now how this looks in the whole picture. So I copied now all the tiles into one folder, and I replaced the tiles with the newer ones from 2019. So we will now load these tiles into OrthoVista all together. So here we go. So this is now our complete data set, and we can now see radiometrically they fit together. Of course, it's not perfect. I should have done for the upper strip, there's some bluish part in it, to do a blue correction here. And in the last one here, we see here there's more intensity, so I should have changed this. But in general, the idea is that these data was influencing the other part. Down here, looking at our starting data that we have here, which is our complete data set. So I will just activate them all, our photos, and here select all, activate them, and then also changing the radiometrics to the source, so selecting all, reset to source. Then we should now see this was our input data, yeah? So data from the 2018, data from 2019, and compared now with our mosaic that we generated here from 2 different flight sessions. This looks now much better and looking more equal spreaded. Okay, I hope this helps to understand how we can run the global tilting with the TLT files from the previous year and replace or influence the global tilting of the new data from it. And of course, with the radiometrics, we can help to bring the data already closer to it, but not changing our other data. Thank you for watching this video tutorial. Goodbye.